Today, we are going to discuss spanning tree. How do you like that? Yes, layer 2 networks. They are cool and important. And though I will be the first one to tell you that a layer 3 routed network is the most optimal network design as a wireless ISP, well, you know what? Sometimes there are layer 2 segments of the network. Or in your last mile, you have layer 2. Or maybe you're running VPLS and you're bridging everything over top of your routed network to have a layer 2 design. Regardless, spanning tree is fucking critical. You have no idea how important it is to understand the basics of spanning tree. In fact, sometimes you'll work with somebody of authority or like whoever, and they'll be like, no, get rid of spanning tree. It's garbage. And it's like, no, you just have to know some caveats. You have to know how it works. You have to set it up properly because you may not think so. A spanning tree is incredibly important to ensure that, well, basically the biggest thing about it, how do I explain this? I fucking hate ADHD. With spanning tree, one of the things you need to remember is that it's there as a safe check. So you've got spanning tree protocol, STP, rapid spanning tree protocol, and then you've got MSTP. MSTP, what that is, where's the abbreviation? I believe it's called multipath spanning tree protocol. Here it is. Where is it? Where is it? Where is it? I'm looking at my cheat sheet here. Oh, there's also VSTP now. Yeah, multiple spanning tree protocol. There we go. That's one of the more recent additions, and I guess there's VSTP as well, but I'm not going to go into that. The whole point of today's video is to discuss spanning tree and the basics thereof, so you can set it up. Very basic. Not going to all the features and functionalities of it. I'm going to include a link in the description that it goes to a Wikipedia page which discusses every facet of spanning tree. Today, I'm going to explain to you guys how spanning tree should be set up on your networks to optimize them and to give you proper functionality, basically. Okay, so we're going to do that today. Anyway, oh, and hello, how are you, beautiful people? So now I've been flapping my gums for 2 minutes. I should probably say, don't forget to like and subscribe. Tell your friends, share this video, help me blow the channel up because I love making these videos for you guys, and I really want to try to focus on that and do some cooler stuff. We also have a Patreon that helps the channel. So if you guys would love to jump onto the Patreon, even $3 a month helps us. So anyway, moving on. Let's get down to the meat of things. Spanning tree, what is it? Well, spanning tree is actually like a function of a layer 2. So it's used in switches, it's used in bridges, which are basically virtual switches within devices, right? Even switches have bridges. Cool, eh? So anyway, its purpose is to make sure that you don't get loops. Hold on a second here. I'm gonna grab a switch. I got a switch nearby. All right, here is a switch. Let me grab an Ethernet cable to demonstrate the most basic loop that you can experience. I know I've got an Ethernet cable around here somewhere. I do. Here's one. So you've got your switch here, okay? Look at this. This is a network switch. I'm looking over here at this screen so I can see what I'm showing. So this is a network switch. You want to see how you create a loop? This is the most basic form of a loop. Assume all these ports are in the same bridge. I've just created a loop. Now, I'm not going to knock down just this tower. I'm going to knock down every single device that participates in this broadcast domain because I've just created what's called an ARP storm, a layer 2 storm. So what's happening is you're getting a MAC address that's originating on one interface and it's coming back into that interface and it's just like, wow, what's going on here? And then if you looked at it on Wireshark, which I'll do another video to demonstrate bad things on networks. If we looked at it on Wireshark or on EtherApe, you'd see just fucking all this multicast ARP traffic all over the fucking network, flooding it with garbage. So this is the most basic loop you can get. Ways that you can experience loops is if you've got VLAN set up and you might actually have a VLAN untagged on another bridge that's also in the same bridge on a different switch. And then all of a sudden you've created a loop inadvertently, right? So what the spanning tree will do in its most basic function is disable one of those interfaces to kind of stop it from happening. Where the hell do I put my drink? So that's kind of what spanning tree does. Now with regular spanning tree, just STP, spanning tree protocol, it will actually disable the port for a specified period of time, usually the default, whatever, the default value, until it doesn't see that loop anymore. And then once that loop is disabled, it'll come back on once it sees that loop go away. So you'll start to see what's called port flapping, which is where switch says, fuck, and it turns off that port, right? Now that port's been turned off because there's a loop. And then after a predetermined amount of time, all of a sudden it comes back on. And then, what happens? As soon as that port comes back up and it negotiates again and starts working, here comes the loop again. And so you have loop on, port off. Okay, loop off, port on. And it just blinks like that, and you'll see the port flapping on your network. it happens, right? It kind of sucks. So anyway, now we can get down to the meat of things. I'm trying to make sure that I cover what you guys need to know without actually boring you or getting too much garbage in there. So anyway, let's take a look at a network here. I've created a very, very simple network. Here's our gateway. This is our main router. So we're just going to arbitrarily say a CCR 1036 microtik, right? Because you know I love microtiks so much. I also love Tycon, by the way. Tycon make amazing products. Okay, so we've got our CCR 1036 connecting to our AG switch, okay? And then from our AG switch, we're going to tower 1, we're going to tower 2, we're going to tower 3, and we're going to tower 4 and 5. So I've just arbitrarily made up devices. I've pulled devices out of my arsehole just so that you've got an idea of something right here, right? Just something relative to you. Okay, and we're also going to actually connect tower 1 back to tower 4 at some point, so I can show you the cool thing about path costs and whatnot. So one of the most basic fundamental things you have to keep in mind is you have to set your bridge priorities. If you do not set your bridge priorities, how do the downstream bridges elect a route path? Well, you might say, what the fuck is she saying? This is over my fucking head. Oh no, it's really, really easy. So if all the bridges have the same spanning tree priorities, it's kind of like, you know, it's flat. So the traffic is just kind of stagnant. There's no elected route path except for where it sees the traffic going. In fact, it might actually elect the route path as a downstream path, which you don't want. You want all shit to flow downhill, okay? Shit being your traffic. Not that your traffic's shit. Okay, so anyway, the way that you make it go downhill is by lowering the number, the actual bridge priority, okay? So we'll go to our root bridge here, and I'm just going to make it 128, so I'll show you. So here's our gateway right here. Let's bring up our bridge on our microtik. Okay, where is our bridge? Okay, I haven't actually set the bridges up yet. Bad, Sarah. Okay, so let's create a bridge here. All right, so we're going to call this last mile because that's how I like to do it. Now, I'm not going into a massive rabbit hole here. I'm just showing you some basic layer 2 setup. So we're going to call this last mile. Now I'm going to go under spanning tree here. Make sure that all of your bridges are using the same spanning tree protocol. RSTP, Rapid Spanning Tree Protocol, is the most common one to use. It's very simple. It's effective. It's elegant. Just use that for now. We'll get into more advanced layer 2 configurations later on. So anyway, I'm going to change this priority. By default, it's 8,000. I'm going to change it to 128. Remember, this is hex, right? So we're going to make this 128. Now, we've got some interfaces here, okay? Where do they go? So port 1 is going to the CCR 1036, okay? And then we've got, it looks like port 8 here is going to what? Let's find out. Okay, so IP neighbors. Let's see here. Port 8 goes to the AG switch. I don't know why tower 1 isn't showing up yet, but we'll take care of that in a minute. So I'm going to relabel this Linux style, old school Linux style, AG. Let's see here. And then we're going to say what port it's on once we figure out what port it's on. So AG switch. All right, there we go. We don't know what port it's on yet, so I'm going to do that. I don't know why I'm not seeing this. What ports is this supposed to be on? Port Ethernet 1. Ethernet 17 to port Ethernet 1? That doesn't make any sense. That's configured wrong. Let me delete this link. Let's recreate this link, okay? So we're going to connect this to port... Oh, never mind. Sorry, I'm having a brain fart here. It's not connected to the gateway. Duh. Okay, so there we go. So that's the AG switch. So we've just connected the AG switch, okay? It's right there. So there's our AG switch. It's now connected. Oh, whoops, I broke things. There we go. It's back up. Tower 1 is back up. I broke Roman. See? Fuck. All right, so anyway, we'll go back over here, and I'll show you what I did. So we've got bridge here, and I've set it for a priority of 128, so it's the lowest number. We're going to add our port to it, which is this AG switch here, right? All right, so that's going to be in there like so. Perfect. Now, this is trunk port, okay, going between two devices, so you can actually enable trusted. That will say, yeah, okay, this is supposed to be here. This is supposed to communicate. It is high priority. It's authorized. You know, it's allowed to do what the hell it wants, right? This is also how we say that this device here is a known device and it's supposed to be there, okay? So you can check that box and hit OK if you want. Okay, next up, let's go to the AG switch now, which is right here. So we're working on this switch, which is this one right here. So we're going to create a bridge here. We're going to call this one last mile as well. Okay, now this is the second bridge in the path here. It's only bridge number 2. So what we're going to do is I'm going to make this 512. I could make it 256, but I want to actually really weight it, if you know what I mean, okay? So now, see how this one says designated port over here on the gateway? Yeah, it's a designated port. That's its role, okay? So now if we go over here, we're going to create our second bridge, okay? Now I'm going to put my ports in it. So what interfaces do we have here? Well, Ethernet 1 goes to gateway, or I'll put this, router, port. Port is it on? It's on port 8. So I'm labeling port 8. So router, port 8, okay? And if you want, you can put a comment on here. so that you know where things are. Because label your shit, for Christ's sakes. Just please label it. All right, so there's that one. And then I believe that 16 goes to tower 2. Let's see here. We can actually, no, I'm not going to do that. I'm going to look here. Okay, so yes, port 16 is going to tower 2. Port 17 is going to tower 1. So let's label those. ETH16, tower 02. Now let's do ETH17. Oh, my anxiety is so bad. I had a coffee before I started this video to try to jack myself up so I'm all energetic and vibrating to make the video for you, and it's just making my heart palpitate. Christ, coffee is a double-edged sword. Hey, phone, I'm going to put you in airplane mode now because you are irritating me. Somebody is messaging the fuck out of me right now, and I don't know where. Whatever. Airplane mode. I'm filming. There we go. In the box you go. Annoying thing. Okay, so I actually booked this time off, by the way, to do a video, so it's just a marketing person trying to get a hold of me right now. It's just like, bugger off, I'm busy. Okay, so we've got our ports here. Okay, let's go up to our bridge now. So we've got our bridge here, and as you can see, it's 512 here, and if we look at the bridge here, it's 128. With 128 being the lower, it's going to flow that direction. There's our downhill. The lowest point is 128. The next step up the hill is 512. You see what I'm getting at here? So 128, 256, 512, and so on and so forth, okay? So here we go. Let's add some ports, and watch what happens when I add these ports. Okay, so first I'm going to add port 16. We're going to add that to last mile. Then we're going to add port 17, okay? See that? So it doesn't know how to do anything because we haven't set any bridge priorities. It's not talking. There's no spanning tree between those other devices. Now watch what happens when I add Ethernet 1. Look at that. See how it says root port? Cool. All right, so that is now, it's elected the root port, okay? So it can see that that port is going in the direction of downhill. That's the upstream. It's flowing downhill, it's going upstream. So ag switch here is connecting to the CCR 1036, which has the spanning tree priority of 128, and this one is 512, so it knows that's the lower number there ahead of me. So I'm going to say that that's the direction that all the traffic wants to go, okay? And right here, I can make this a trusted port. Okay, because that is a port that we don't necessarily want to go offline if there is a loop, okay? And now I'm going to go over here and I'm going to do this, trusted, like so, right? There we go. So that's a trusted port now, right? So now let's go to tower 1. This is kind of an end of line right now, right? So watch this. Okay, so root, and I'm not going to get into path cost priorities yet. I already did a video on that. It's called layer 2 failover, I believe. I'll put a linky boxy on the back of the video, or a link in the description for you. Okay, so let's do this. Let's create the next one, last mile. Now this one is switch number 3 in this series. So I'm just going to arbitrarily, I mean, I could do my math. Let's get a calculator out. What is 128 times 3? 384. What's 128 times 4? 512. Okay. 128 times 5, 640. Okay. 128 times 6, 768. So why don't I just make this one 768? Okay. And I'm going to talk about the caveats to spanning tree on multiple platforms shortly. I want to try to keep the video short. I don't want to make it too long, and already I feel like I'm bloating it up with fucking yammer. Okay, so here we go. So I've set this one for 768. We've got 512 here, okay? I'm kind of jumping. I'm doing like every 2 so that it's got a lot of weight to it. It's not a minor difference, it's a major difference, okay? So now let's see what we got here. What are our neighbors? Well, Ethernet 1, that's the only one. Okay, so let's label Ethernet 1. All right, ETH1 equals, let's see here, ag 0, port, and we're on port 17 on here. I can actually, on GNS3, it's kind of cool. I can hover over it. Hey, GNS, don't make a liar out of me. There we go. It's Ethernet 17. Okay, so I'm putting port 17 there. All right, so now let's go back to the bridge now that that's labeled. Oh my God, this coffee. Now, this is our upstream port, so we can make that one trusted or not in this case here, because we're starting to get into the infrastructure. I'm not necessarily going to make that one trusted. Okay, so we've got our root port here now. So it's saying that that is the upstream interface. It's seeing that this one here has a lower priority ID from this one, which makes it higher priority. Kind of counterintuitive, weird, eh? So this one's 512, so it's higher priority than this one, which is 768. Now watch, here's where things get a little bit different, okay? So tower 1, I'm gonna move this aside for now. We're gonna just move tower 1 aside, and I'm gonna bring up Winbox, and I'm gonna go to tower, let's see here, 2. Okay, so where is tower 2? Tower 2, the net power 16. Let's move this one over here now. Okay, so I've got this one right here. All right, so tower 1 and tower 2 are kind of adjacent to each other. I did that on purpose because going in either direction, these two aren't connected to each other, but they're at the same point in the chain of routers and switches and whatever the fuck's on there. Okay, so let's take a look at tower 1. Okay, so now if we look here, if we check out the bridge priority, we can create our bridge over here. And because this is the third device in, I'm actually just going to make this 768 because it's the third device in the other direction now, okay? See, this is 1, 2, 3, 3, 3, and 3. Both of these guys are 3. They are device number 3. They're bridge number 3, okay? They are priority number 3. We're going to set that. Okay, so now you'll see that these two, they don't talk to each other right now, right? If you made these guys talk to each other, then you would have to actually set this priority different. You'd have to make it either a step higher or a step lower, depending on how you want the traffic to flow through the network. Seeing as this is directly connected to this one, then you'd have to make this one here being the end of line. You would make this one actually a step higher than this one so that it knows that it wants to go this way. The reason why I decided to make this one the step higher, Tower 1, than Tower 2, is because Tower 1's an end of line right now. So it is lower priority than all this stuff over here. Okay, here we go. All right, so moving forward, let's add our interface to this. And don't forget, if you guys have questions, just leave it in the comments below. There we go, root port again. I have no problems answering questions for you guys online. Remember, we're keeping this as simple as possible, right? Okay, so Ethernet 1 is going to AG switch 0, and it's going to port 16. I already know that one because I already set it up. Okay, here we go. There we go. Port 1 and Ether 16. There you go. So that one is now set up. So now we have our root port, see? Because Tower 2 is downstream from the AG switch. The AG switch is upstream from Tower 2. So if we look at the bridge priority here again, where is AG switch? Actually, I'm going to move, now that we're done with the gateway, I'm just going to move the AG switch up here because that's the thing that's doing a lot of magical stuff, right? Okay, so if we look here, it's 512. Both this bridge here are 768 and this one's 768. So both these guys know that the upstream port is Ethernet 1, okay? So now let's add some more ports here because we're on Tower 2 switch, right? So we're going to put Tower 1 right here. We're going to go back into this switch right here, okay? I know that I'm using routers, by the way, but that's because I've labeled them as MikroTik devices, and most MikroTik devices are capable of routing, but don't forget, if it's a MikroTik switch, it's not technically a router. I mean, it uses router OS, but until I think router OS 7 is supposed to turn the 3 series switches into layer 3 switches, so it's not there yet. Don't route on a switch. I'm just using these symbols arbitrarily right now. I could put switches, but this will make more sense to you guys, just okay? So anyway, that tangent is done. Ethernet 16, there's only one active interface on here, and if I look here, I can clearly see, you can see here, Ethernet 1 goes to Ethernet 16, so this one is the one that goes to Tower 3. So ETH 16, Tower O3, port 1, like so. Cool, so that one's in there now. So now, by default, Tower 3, let's bring up Tower 3 now. Where is Tower 3? All right, here's Tower 3. I'm going to move this over top of Tower 1 for now, because we don't really need Tower 1 at this point in time. We're going to start going downstream a little bit further. I'm moving them to the left for you. Okay, so here we go. So let's go back to the bridge here, and now I'm going to add Tower 3. We're going to add it to the last mile bridge. Designated port, root port. Interesting, no? Let's create our next bridge well, first, actually, sorry, I'm jumping the gun. See, ADHD, I've got ADHD brain. It's all over the freaking place. Okay, so we can see what devices are where by going to IP neighbors. And since we're using Roman and not layer 3, we can see everything that's, entangled, everything that's on whatever interface, see? So look at all this stuff on Ethernet 1. Those are all the other devices that are in that bridge in that direction. Then we've got 4 and 5. Okay, so let's label all this shit. Okay, so Ethernet 1 goes to, let's see here, Tower 2, and it goes to port. What port does it go to? It goes to Ethernet 16. Here we go. I like to label things. Labeling things is great. Remember, if you label things, you won't get lost. It's like leaving a trail of breadcrumbs. Remember that. Okay, so Tower 5 is on Ethernet 4, and Tower 4 is on Ethernet 5. I should have thought about that better. Yeah. Remember, ADHD. Okay, so there we go. So Ethernet 4 is actually Tower 5. And it's going to be port 1 because that's the way that I set them all up, okay? If I want to verify that, okay, Tower 5, port 1 to Ethernet 4. Yes, okay, so that one's labeled. And Ethernet 5 is Tower 4. Here we go, port 1. Cool. So now we've got all that stuff labeled and in place. All right, nicely. Let's add these. So right now, the bridge is set for default on Tower 5 and Tower 4. And if I go to the bridge here that I'm about to create, okay, the third tier bridges here are 768. So I'm just going to jump to 1024 now, okay? We're just going to go to 1024 for Tower 3 now, okay? And then these guys here will be, let's see here. So we're at 128 times, what is it? Where's my calculator? No, I don't want you full screen. What are you doing? I'm an old fogey. Yeah, here we go. Okay, so 1024, ugh, so that's 8. Okay, so yeah, base, what is it, base 16 or base 8, whatever. Okay, so then if we want to go, so we're 8 there, so let's go 10. So 128 times 10 would equal 1280. So then we're going to make tower 5 1280. Now this one here is going to be a little different. We're going to do some weird shit over here, okay? Because this is where we're going to create a loop back to the front of the network, which will actually share a shorter cost path per se. Because we go, let's see here, let's measure that. 1, 2, 3. 1, 2, 3, 4. So this is actually a longer path cost here. So we're going to set this one differently because we don't want the traffic from here to go this way. Let's see here. 1, 2, 3. 1, 2, 3, 4, 5. Yeah, so we don't want the traffic from here to go here. So we're actually going to make this one a higher priority still because we want this one to follow the shortest path first in case there's a fault, okay? So here we go. This is going to be 1024 on Tower 3 PowerBox Pro here, okay? So now let's add our ports. So I'm going to add Tower 5 and 4 first so you can see what happens. What did I just add? God damn. Coffee is such a double-edged sword, man. My heart is racing. You have no idea. Oh, is man politically incorrect? Oh, coffee is such a terrible drug person, people. See, none of that sounds good. Man, yeah, man. I'm a hippie. Whatever. Fuck it. Okay, so let's add this. So now there's our upstream interface, and it's elected the root port again. Why? Because this is 1024. Tower 2 is, let's see here, 768, right? And actually, something's bothering me right now that I'm going to fix. Oh, thank God. So see, designated port, root port. Yay! I can't wait to demonstrate breaking this shit. It's going to be fun. Okay, so here's our ports, right? All right, isn't that cool? And so there's a couple of ways that we can elect which path the traffic's going to go depending on how the network is operating. So I can actually make this one 1024 as well, or not 1024. I can make these two 1280. 1280, but then I can also say, well, you know what? I could also weigh it this way or I can weigh it this way. That's where the cool stuff comes in. We're almost at that point. So now our Tower 3 is set up. I'm going to move it aside here. We're going to bring up Tower 4 and Tower 5. I hope you guys are starting to pick this up now. I'm supposed to be keeping the videos down to 18 minutes or so because I guess they can get a little bit long-winded, but I also don't want to cheapen what we're doing here. I need you guys to understand what I'm doing. I need you guys to follow me on this, okay? So here we go. We've got Tower 2. We don't want Tower 2. We want Tower 3. So we can see our ports here, okay? So here we go. It's a bit of a mind bender now. We're getting into the weird shit. Okay, so this is Tower 5. I'm going to bring up my calculator again. Oh, yeah, it's 1280. Duh. Here we go. So 1280. Okay, so there we go. So there's our bridge here. Remember, this is 1280. This is 1024. So Tower 4 is downstream. It has a lower priority than the upstream bridge, which is 1024. Okay, now we've got our bridge. Let's label our interfaces. So I'll go to IP neighbors here, and you can see everything's on Ethernet 1. So clearly Ethernet 1 is the one that takes us back into the network, okay? So Ethernet 1 is connected to Tower 3, okay? So let's see here. And what port is it on? Let's check that out. Oh, actually, you know what? I can look over here. Watch. I shouldn't be cheating with GNS3 because if you guys are in the field, you're not using GNS3. You're looking at your routers and switches. So we've got Tower 4 here. We're at Tower 4. Tower 4 is on Ethernet 5. So we're going to go port 5 here, like so. Now let's throw that into the bridge. There we go. And what is our role going to be elected? It has elected that as the root port. Okay. See, it didn't say root over here, just a designated port. This is the root port coming back this way. And now let's get Tower 4, Tower 5. Sorry. Oh shit, where's my Roman? Let's see here. Neighbors. Oh, hold on. Nope. 172.30. There we go. I want to connect to Roman. Why isn't my Roman there? That's annoying. I'll have to reopen Winbox. 1 second. There's my Roman. Hey, Microtech, maybe you guys should fix that. And yeah, 172.31.200.30. For some reason, acting up now. I'm assuming that that's probably GNS3 being weird. I should have a, where's my gateway? I don't actually have the gateway up anymore. Let me see if I can bring it up. There we go. Okay, so tools Roman. Okay, IP neighbors. Yeah, okay, so our gateway is there. So here's our gateway, but for some reason, it doesn't want to activate Roman. Let me try clearing the cache. Clear cache. There we go. Connect to Roman. Awesome. My demonstration video is here, and Roman just shit the bed on me. Good job, Microtech. Good job, GNS3. Thank you. I will throw you under the bus for that. All right. Well, you know what? What we'll do here is, let me just, Christ almighty. I can't get into Roman. That is so annoying. All right. So what we'll do here is I'll just bring up, I don't think I've got Tower. Well, I do have Tower 4. I just don't have Tower 5. So let's see here. What can I do about that? Because that's the one that I really need right now, and that's going to piss me right off. I can't fucking use it. Let's create. We're going to go into the... Nope, that's not going to work either. God damn it. Okay, I'm going to pause this for 1 second while I fix this, because sometimes GNS3 can be very glitchy, as can Winbox, okay? Don't hold that against Microtech. It's just we're working in a lab environment, and sometimes software doesn't work great, especially on Windows. So let's pause this for a second. All right, we're back in business. I actually had to reboot the artificial gateway here, gateway CCR 1036, to get Romon to work again. I think it's because I had so many windows open, and this is a virtual machine running, right? So anyway, now that that's back up and running, I need to shave my arm. I'm getting all hairy. Okay, so we're going to program Tower 4 now. Okay, so Tower 4 here. It is actually, if you really think about it, look. 1, 2, 3, 4. I mean, that's a long path. 1, 2, 3, 4, 5. So realistically, it's going to elect this path first. But let's program it. Let's program this one is 1280 as well as this one is 1280. And it will elect this one because this one has the lowest priority. But this one will probably go this way because this one has a lower bridge priority still, right? See where I'm going with this? And let's do a little live experiment right here and fiddle fart with it to get it configured the way that we want it. This will be the cool part of it, right? You've already seen me fucking program 1, 2, 3, 4, 5 bridges. Let's do this one differently. Okay, so Tower 4. So we are on Tower 4 right now. Oh yeah, I needed to do Tower 5, but anyway, you get the idea here. We'll do Tower 5 quickly. That's one more. Okay, so Tower 5, where are you? We haven't done Tower 5 yet. So that one's connected to Tower 3. Okay, so we're going to go to IP neighbors here. Tower 3, everything's on Ethernet 1, so that's our upstreaming interface for sure. So we're going to go ETH1, Tower 3. Port. What port is it on? What port is it on? Since we're on Tower 5, that's on Ethernet 4. So port 4. Perfect. Let's create our bridge here. This is the last one we're doing. This is kind of an end of line out of the middle of nowhere. It's an armpit. Okay, last mile. This one's 1280, just like Tower 4, okay? Because these ones are on the same tier. This is the upstream. These two are technically the same as these ones in the sense that they're on the same latitude, I guess you could say. Okay, there we go. And let's add our port. Ethernet 1 to last mile. Look, it's going to be elected root. It's root. And also, by the way, look at the root paths on here as they've been changing. Look, 40. Okay, and where is our root path here? 30. See how it's decreasing as we go forward? So 40, 30, 40, 30. This one will be 20. So if we look over here, oh, this one's 10. Ooh, interesting. See? 10. So the, ag switch is 10. Sorry, let's see here. So Tower 2 should be 20. Do I have Tower 2 up? I don't think I do. Okay, Windbox just shit the bed again. So this one is 4. So 1, 2, 3, 4. Yep, 1, 2, 3, 4. And this one's 3. So 1, 2, 3. And then this one is, let's see here, ag switch is 1, right, to there. And this is the base bridge. This is the lowest priority bridge. So 1, 2, 3, 4, right? So this one's going to be 40 as well. So let's go and look at, where is number 4? Here's number 4. Look, where's our ports? There we go. See? 4. Okay, so now let's do the cool part here. So we're going to get rid of all this shit. So we've got 4, 3, and 1 now. Okay, so we're going to get rid of the ag switch. I'm just going to move it off screen. And since our common denominator here is going to be 4, I'm going to put 4 right here. And then I'm going to have, we don't need 5, we need 3 and 1. Okay, so here we go. This is going to be the cool part. All right, so Tower 4 doesn't have a connection to this yet, so let's create one. Let's go from Ethernet 24 on here, the last Ethernet port, to 6 on here, okay? Just for shits and giggles, okay? So now that's in place. Let's take a look at, see here, Tower 4, and we're going to see another neighbor now. Neat, eh? Ethernet 6, we see Tower 1. So now let's go over to Tower 1 for a second. Ethernet 24, we see Tower 4. Let's label our interfaces. I love science. This is great. Where are all my interfaces? There we go. So there it is. So ETH24, and that's going to be Tower 4, port 6. Okay. Oh, this video is getting long. We're up to like 36 minutes. I hope that Yuya, the master editor, can shave it down just a little bit without getting rid of any valuable information. Okay, so that's labeled. Now let's add that to the bridge here. 24, last mile. That's in there now. Designated port. It's not elected a root. Okay, so now let's go to Tower 4 and label this. Okay, so this will be ETH6, and this is going to, this is Tower 4 we're in. This is going to Tower 1, port 24. Cool. Now let's go to our bridge and add it and see what happens. This will be kind of cool. What's going to happen here? Oh, isn't that interesting? It elected port 6, the root port. And why is that? I'll show you, okay? So remember, Tower 4 is in the middle of 3 and 1. Now watch. If we look at Tower 3 now, and we see the bridge priority, it's 1024. And if we look at Tower 1 and see the bridge priority, it's 768. So it's saying that that path is lowest, so it's going to go that way. So now, do we want it to go that way? Well, let's see. Tower 4. So 1, 2, 3, 4 to the gateway. And let's look at it now this way. 1, 2, 3, 4. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. All right, so wait a sec. That map doesn't make any sense. 1, 1, 2, 3, 4. Yeah, hold on. Yeah, it's 3. Why am I counting wrong? God, I hate coffee. 1, 2, 3, 4. 1, 2, 3. So this is the shortest path. So like open shortest path first protocol, what spanning tree is doing now is saying, well, tower 4 going this way is going to have a shorter path to go this way. So I want the traffic from tower 4 to go this way instead of this way. But watch what happens if we kill number 1. Okay, so we've got tower 4 here. All right, so this is going to be our little guinea pig here. Let's go over to tower 1 and disconnect that port, all right, and see what happens. Hopefully it doesn't crash Roman, because Roman is now acting up because I've got so many interfaces open. God damn it. Okay, so here we go. We're going to turn this one off. Now watch the bridge up here. I'm going to turn off port 24 on port 1, and now we should see our path change if that router didn't just boot me out, and it did. Oh, you bastard. There we go. Good. Let me back in. That's because we just broke layer 2 on this particular device. So now look, this should actually be better because I'm adding an interface now. So you'll see now that because I've turned off 24 on here, so the link just went down, it's automatically rerouting in a different direction. It's going now through tower 3 because tower 3 is the shortest path back rather than tower 1, because tower 1's gone. There's no link to tower 1. It's gone. But let's turn it back on and see what happens other than Roman crashing. Did you see that? Did you see what just happened there? The role changed. So as soon as I turn this back on, tower 3 port 5 lost its root designation, and root designation went back to tower 1. Ethernet 6. Now, because this is already relying on Ethernet 1, I might be able to turn this off without Roman crashing again. Can I do that? No. Roman changed its designation again. But note, look. So every time I change this, it's going to do that. That is so irritating. Please don't be this way. Tower 4. You're fun to work with, aren't you, GNS? Maybe I'll check out Eve. I don't know if I should be blaming Eve or if I should be playing, or GNS3, or if I should be blaming Winbox for having a hard time working with this shit. Yep, good job. Roman agent not found added to... Come on. Let's try this. Don't be poo-pooing my critique, by the way. There we go. Here's tower 4 back. So now you'll see that as long as this is active, now that... Oh, and by the way, leave in the comments below if you can explain why what just happened and how I can avoid doing it in the future, because we're not all perfect and we're not all geniuses. We just have strengths and certain skill sets as we're growing as human beings, by the way. So also don't fucking shred me for that. Anyway, look here. So because this path is back up, this path to tower 1, look, it's being elected root port again, right? And now this one is the alternate port. So what that's saying is that if this link breaks here to tower 1, all the traffic's going to go back this way, because that becomes naturally the shortest path because there's no other way to go, right? And I guess alternatively, I don't know how many ports I've got on the gateway. I could do a direct port from here to here, and you'll see. So by setting the path priority, by setting the bridge priorities on these guys, you're saying the traffic can go this way, a certain way, right? So we'll look at the bridges again here. So 768 on tower 1. And if we look at the bridge priority on tower 3, it's 1024. So it's a higher number, meaning lower priority. And if we look at tower 4 here now, you'll see that this one's 1280, so even higher still, okay? So with tower 4, the shortest path for it to go back is going to be this bridge here to this bridge to this bridge, because this actually has a lower number. It's going to take the lowest number first. This one here, tower 3, has the higher number. So it's not going to go that direction first. It's going to go this way. But if this one disappears, the next lowest number in line is tower 3, so it's going to go there. Does that make sense? 1280, 1024, 768. So this is a very basic example of how you can actually create a mesh network. And by the way, look, no loops anywhere on here in this infrastructure. There is a massive loop here right now because I have actually created a literal loop. But if you look in the logs here, we've got no layer 2 issues because we set the bridge priorities. If I set all these bridges to exactly the same priority, ag switch, tower 2, tower 3, tower 4, and tower 1 to 8,000, which is the default, this fucking thing would go nuts. It would be like, holy shit, we've got a loop, because all the bridges have the same IDs, like the same priorities, right? So it's going to say, well, I can go in any direction. There is no order here. This is absolute fucking anarchy. Ah! It's flat. Remember, shit rolls downhill, right? So you want to make sure that the shit knows where to roll. Otherwise, if you go like this, it's just going to roll back and forth, and you got a fucking nightmare. Bridge priorities are critical in layer 2 broadcast domains, okay? Whether you're using Cisco, Juniper, HP, Nokia, Adtran, Huawei.
From your calendar.
Yeah, fuck off. Anyway, that's the important factor that you need to consider. So I actually have consumed 43 minutes doing this little explanation and whatnot. I hope I don't need to redo it after I send it off to review, and I've got a booking in 10 minutes. So there you go, guys. There is layer 2 bridge priorities and whatnot. I feel like I might not have been complete enough on it. So if you need more clarification, leave that in the comments below, or you can also hit me up directly on Patreon. You can actually message me on there and I'll help help you with things, whatnot. So there you go. It's as simple as that. That is essentially the most important factor. In summary, make sure that all of your switches and bridges have the same spanning tree protocol, and make sure that you set their priority number in increasing hexadecimal order from the beginning up. 128, 512, 768 for these two, 1024, 1280, 1280, right? So that the bridges, the spanning tree, can actually do its job and elect the direction that the data is supposed to go. Otherwise, if all those bridges and switches have the same spanning tree priority, the traffic doesn't know which direction to go, and you get a loop. That's the basic functionality of spanning tree. And a lot of people get that wrong, because layer 2 can be a little tricky to wrap your head around if you don't spend all of your time in it, but it's your friend. And I'm not saying make your network flat and bridge, because there's all sorts of other issues that can arise if you do that, especially if you're a wireless infrastructure and not a wired infrastructure like coaxial or fiber or a DSL or whatever you're using that's physically connected infrastructure, okay? Which is another rabbit hole I can go down. So don't forget, like and subscribe, leave your comments below. If you guys want to show love and help me with the channel, join our Patreon, because that really does help feed us and helps us get more things for the channel. And it also helps to pay our editor, Yuya. Yuya's awesome. So thanks for showing up, guys. And yeah, hopefully this 45-minute video will get shaved down a little bit. I hope you guys enjoy. Have a great day.